All right, sixth graders, today we're talking about equal fractions. And I want to focus on this term equal for a second. Okay? Equal fractions. What do equal fractions mean? What does it mean to have equal fractions? So, look at this first model. In both of these models, one piece is shaded. Okay? 1/2 and 1/4. So, the top numbers are equal, but the bottom numbers are not equal. And you can see from the drawing that these are not equal amounts, are they? So, if we're talking about equal fractions, we are talking about what exactly? What does this say? Hayden?
Like 3/6 is the same as 1/2. They have to be the same kind of thing, equal amounts.
Equal amounts, yeah. If you have 3/6 of something and 1/2 of something, what's equal about those is the amount that you have. 3/6 is 3 out of 6 is half of the amount. All right. So in order to have equal amounts, it's not the numbers that are equal. It's actually the proportions of the numbers that are equal. Okay? And you will always have equal amounts when you're talking about equal fractions. It's just that the size of the pieces are different. Okay? Fourths are smaller than halves. And that's why 1/2 is more than 1/4. Or 1/4 is less than 1/2. Okay? Because we're talking about the amount that you have. So let's talk about getting equal fractions. What you do to get an equal fraction is to multiply or divide the numbers in the fraction by the same number. So in this case, if we have 1/2 and we multiply it by both numbers by 2, then we have an equal fraction, 2/4. Or if we're starting with 2/4 and we divide both numbers by 2, 2 divided by 2 is 1, and 4 divided by 2 is 2. It's kind of like cutting this one in half. Okay? So we're going to be multiplying or dividing both the numerator and the denominator by the same number in order to get an equal fraction. By making the pieces bigger or smaller, we're going to write an equivalent fraction. All right? So let's go to your worksheet and do some of these together. Number 1. So we're starting with a fraction of 3/5. 3 out of 5 pieces. And in order to change it to pieces that are in 20ths, you have to multiply that 5 by what number? Maya?
4.
By 4. Yep. Times 4. That dot means times. Dots between the numbers, not the decimal point dot, but the dot between the numbers in math means multiplied. So if we multiply 5 times 4, you get 20. And in order to get an equivalent fraction then, you'd have to multiply the top number by the same number. 3 times 4. What's 3 times 4? Melina?
12.
12. So 3/5 is equal to 12 20ths. And we multiply both numbers by the same number. We cut them. We cut that first fraction into smaller pieces. So we have 12 20ths. That's what finding an equivalent fraction is about. Now, in this case, we're starting with numbers that are bigger numbers and making the pieces, making the numbers smaller or making the pieces bigger. So we're going down from 12ths down to 7ths by putting the pieces together in this case. And we're going to put them in groups of what? How do you get from 21 to 7? From 21 to 7, Kaden? How do you get from 21 pieces down to 7 groups? Not subtract. We're going to put those 21 pieces into groups of 3. Yep. If you put those 21 into groups of 3, you get 7. If you put 12 into groups of 3, 12 divided by 3 is 4. So 4 sevenths is equivalent to 12 21sts. Okay? Now, what are we finding here? What is it? What is the process? We're finding the factor or the multiple of a number, aren't we? Just like what we worked on in the last chapter. From 20 to 60. What factor is that? Maya? Multiplying by 3. Yep. And so if we multiply 12 times 3, you get 12 times 3 is 36. Okay? 1/2. If we're starting with 1/2 and we work this way, how would we get to 15? 1 times what equals 15?
15.
Thank you. 1 times 15. So 2 times 15 is what we have to find.
30.
30. Okay? It's all these basic facts, multiplying by 2, multiplying by 4, dividing by 3. We're finding all of these basic facts. All right? Now, let's talk about simplest form. A little bit down to the next section. Number 7. Simplest form means that they don't have any common factors. And that the denominator is not a multiple of the numerator. In other words, the top number doesn't go into the bottom number. So, let's start with 20/80ths. Remember when we were factoring these? Remember when we were making the factor tree?
Yeah.
And you could figure out, based on looking at both numbers and using the rules that we learned, you could figure out what numbers go into both.
Yeah.
Okay? Or what could you divide both of these numbers by?
20.
By 10. Or 20. 20 is the greatest one. If we divided both of them by 20, what would you get? 1 and 4. Yep. What if you didn't start with 20 though? Could you start with 10? Yeah. So 20 divided by 10 equals 2. And 80 divided by 10 equals 8. But 2/8 is not simplest form because you can take out the 2's out of both numbers. If you take the 2's out of them, or divide them both by 2, and then what do you have? 1/4. See, you get to the same answer just by continuing to divide. Even if you don't start with 20, if you keep dividing, you can get to the same answer, and that's simplest form. Okay? How about this one? What do both of these numbers end in? 5, right?
Yeah.
So we know that they're both divisible by 5. We're using the divisibility rules. What's 45 divided by 5? Bella? 9. What's 55 divided by 5? Maya? 11. Now, 9/11. How do you know if that's simplest form? There's a couple things that we want to look for. Maya?
Well, nothing goes into 11 except one of them.
Yeah, that's it. 11 is prime. 11 is a prime number. So once one of them is a prime number, then we can't necessarily stop there, because what if the top number is a prime number, but it goes into the bottom number?
Yeah.
Like in 2/8, 2 is a prime number, but 2 goes into 8. So then we have to factor out the 2. Okay? Once you have one of them as a prime number, then you just have to check and make sure that one is not divisible by the other. 9 doesn't go into 11, so you can stop. You know you have simplest form. Okay? Even though you could divide 9 by 3, you can't divide 11 by 3, so you have to stop. Okay? That's how you know you have simplest form. If one of them is prime, and it doesn't go into the other one, okay? Or if they're both composite numbers, but they don't have any common factors. They're not both divisible by 2, or by 3, or by 5, and so on. Okay?
On the back side, what do you have to do?
On the back side. Oh, are there any questions about the process yet? Do you understand how to find simplest form? All right, let's go to the back side then. In your assignment, do the evens 2 through 18. And the bottom 4, problem solving. Okay?
Okay.
That's it. Yay, math.
Okay, everyone.